Just as we multitask in our daily lives, juggling a long list of must-do activities, our computers also multitask to enable us to check our email, browse the internet, stream movies, and more. To bring us the best computer experiences, components in our computers are built to share the work required to run one or more applications. RAM, which acts like your computer's short-term memory, is one of those key components. If your computer or laptop's RAM doesn't have the right capabilities or capacity, it will function very poorly if it works at all. Read on to learn more about RAM and whether it's time to upgrade. RAM is a common computing acronym that stands for Random Access Memory. Sometimes it's called PC memory or just memory. In essence, RAM is your computer or laptop's short-term memory. It's where the data is stored that your computer processor needs to run your applications and open your files. Inside your computer, RAM typically comes in the form of a rectangular flat circuit board with memory chips attached, also referred to as a memory module. Computers typically come with at least 2 RAM modules with room to add more, if needed. These RAM modules are critical components that work hand in hand with your computer's central processing unit, CPU, and must be working optimally for you to have a good experience. Anytime you play a game from your computer's hard drive or stream a movie from the internet, your computer loads the data that the CPU, or processor, needs for those applications into the RAM. The CPU then uses this memory to perform the complex tasks required to deliver your desired experience. That's why RAM needs to be faster than the long-term storage offered by your computer's disk drive. The speed of your RAM determines how quickly data flows in and out of your CPU. If your RAM is too slow, you'll spend a lot of time looking at the spinning wheel cursor. You can think of RAM like your own short-term memory, which helps to store the immediate data you need for tasks like remembering your shopping list as you walk through the grocery store. If you were to lose your short-term memory, you wouldn't be able to remember anything for more than a few seconds. But having more short-term memory would allow you to do additional simultaneous tasks, and those tasks can be more complicated. Similarly, the higher the RAM memory capacity of your computer, the more quickly your CPU can complete its work, and the smoother your experience will be. RAM also allows you to use demanding applications, such as video editing software, and enables you to open larger files. We'll cover how much RAM you likely need later in this article. It's important to distinguish between RAM, short-term memory, and the long-term data storage on your computer's disk drive, also known as the hard drive. Disk drives, whether they are traditional hard disk drives, HDDs, or newer solid-state drives, SSDs, are used for long-term data and file storage. RAM only holds the data you need for the apps and files that are currently open. When you close an app or shut down your computer, the data is cleared out of the RAM. That's why it's important to save your work to your disk drive before quitting. If you ask your computer to perform a task, such as opening a photo to edit, and you don't have enough available RAM, your computer has to begin shuffling data around in order to open the file. Imagine someone asked you to gather up a bunch of tennis balls left on a court, but there were more than you could easily carry in your hands. You would have to start shuffling the balls around and stashing them in pockets or in your arms in order to move them all at once. Similarly, if your computer doesn't have enough RAM, it has to move data between your slower hard drive and your RAM and your processor, which causes everything to slow down. The amount of RAM your computer needs depends on what you're using your computer for. If you use it only to watch videos and respond to emails, as little as 4 GB can get you by. But if you want to edit photos or play video games, you should start with at least 12 GB of RAM, and go up from there. If you want an experience without compromises, you need at least 32 GB of RAM. This would allow you to run powerful apps, like Photoshop, as well as play the latest games with a good frames per second, FPS, rate. Demanding computer users will need 64 GB and above to unlock the full potential of their games and apps. A good rule of thumb is to look at the RAM recommendations for the applications you use most often and then compare the total amount needed to the amount of RAM your computer currently has. There are many ways to see how much RAM your computer currently has and how much RAM your computer is using. Both pieces of information are important. The fastest way to find information about your computer's RAM is to access system information using the computer's task manager. To open the task manager, you can use the search bar in or near your computer's start menu. Or you can press the Ctrl, Alt, and Delete keys simultaneously on your keyboard, then click on Task Manager. In the Task Manager window, locate and click on the Performance tab, then on Memory. The memory view will tell you how much RAM you have in total, how much you're using currently, and how many memory slots your computer has and is using, as well as additional usage information. It's important that you have a large amount of available RAM. If your RAM usage is running between 80 and 100% for a sustained period, your computer doesn't have enough memory capacity. Beyond looking at how much of your RAM capacity you're using, there are a number of signs that may indicate your RAM is not up to the tasks that you demand of it. You see that your PC is using more than 80% of its RAM very frequently. Files open very slowly, especially large files. Your computer frequently crashes and or your apps often freeze. Apps and websites open very slowly. Opening multiple apps causes a big drop in performance. You receive a message that your PC doesn't meet the minimum requirements while trying to install an app. If you experience several of these on an ongoing basis, it may be a sign that it's time to upgrade your RAM or upgrade your computer to one that has the capabilities you need. One of the most cost-effective ways to improve your productivity and enjoyment while using a computer is by upgrading your RAM. Many computers, even many laptops, have expandable RAM slots, and experienced users can purchase and install individual RAM modules to expand existing computer memory. You can also have a professional do this for you. In the long run, though, upgrading isn't really optional. The software we all rely on is continuously being updated, adding more and more demands on your computer's hardware. Additionally, the technical standards for RAM are continually changing, so after a certain amount of time, your upgrade options and PC won't be able to keep up. Before deciding to upgrade your RAM, you may want to consider how well your current computer is supporting your needs overall and if it might be time to purchase a new one. Random access memory, commonly known as RAM, is a temporary storage location where data can be retrieved or rewritten in any order to support the real-time working of computer and mobile applications. Without the ability to store and retrieve data fast, none of the applications or other functions would work properly. This is where RAM comes into play. RAM, or random access memory, is among the essential components of a computer system. It is a short-term memory bank wherein data that must be retrieved quickly is housed. RAM maintains data readily available so that the central processor unit, CPU, may locate it without requiring it to access long-term storage to perform urgent processing duties. RAM is included in all computing devices, including desktop computers, operating on Windows, MacOS, and Linux, tablets and smartphones, running on Android or iOS, and even Internet of Things, IoT, devices, like a smart TV. RAM is also used to refer to a device's short-term memory. It reads data that a program or operating system may need in the near future and temporarily stores it for easy access by the CPU, graphics card, and any other component that may require it. This information remains available in RAM until the application or device is closed or restarted. The RAM is then cleaned and prepared to accept fresh, appropriate data. RAM prevents other components from accessing slower storage, such as a hard drive or a solid-state drive, SSD, whenever you open a new browser tab. While current storage is faster than older drives, it is still significantly slower than RAM. However, these storage components are required because they allow longer-term data storage whenever the RAM is not in full functional status. RAM is dubbed random access because any memory cell may be accessed directly if the row and column that overlap at that cell are identified. Serial access memory, SAM, on the other hand, stores data as a sequence of memory blocks, which can only be retrieved consecutively, like a cassette tape. If the information is not in the present position, every block is examined until the required data is located. SAM functions exceptionally well for memory banks where data is typically stored in the sequence in which it is utilized. In contrast, RAM data may be retrieved in any sequence. When the hardware on Pentium CPUs was built, users rarely required more than 8 MB of RAM, or 32 MB if the system was being used for business. That was sufficient for running Windows 95, the earliest Microsoft Word versions, and earlier PC games. Currently, a web browser with multiple tabs open may easily take over 2.2 GB of RAM, making 4 GB the minimum requirement for PC RAM and 3 GB for mobile devices. The amount of RAM required depends on your applications and programs, the number of Windows users have open at once, and the desired user experience. The more RAM a system has, the quicker it operates. Replacing the RAM or other components may be necessary when a device is outdated. All active applications, including browser tabs, use RAM. When a computer's working demands exceed the quantity of RAM available, the operating system must shift a program to the hard drive. When you return to the program, it must retrieve the data before you can continue working. This is known as paging or shifting, which takes some time. The process leads to delays and impaired functioning. Customers who purchase a PC will have various RAM capacity choices: 4 GB, 8 GB, 16 GB, or even additional memory, 32 GB, 64 GB, if they use advanced editing tools or graphics applications like CAD. Remember that RAM is not the same as storage. The information stored in RAM is lost when a computer is shut down, whereas data placed in long-term memory devices, SSD or HDD, is retained. RAM performs the following key functions. 1. It acts as a temporary storage location. This is the main use of RAM. When a user saves a file or any other data type, the information is transferred to the hard drive or another form of long-term storage. In addition, when you quit an application, the operating system removes it from the RAM, freeing up space in the computer's short-term memory so that you can begin your next task. RAM is only intended for temporary storage. Therefore, all of their work may be lost if the user hasn't saved a file to the hard disk drive and the power goes out. However, modern applications may have a mechanism to store a copy of the file in an embedded backup system to help recover it later. 2. It makes it possible to read files faster. RAM is utilized to rapidly retrieve data, which is required for reading any file's contents. Depending on the technology and job, random access memory may process data anywhere from 20 to 100 times quicker than data stored on a hard drive. If users open a document previously stored on the system, the operating system identifies the file in its long-term storage and replicates its contents into RAM. Once the data is stored in RAM, the user has near immediate read and write capacities due to RAM's lightning-fast speed. However, attempting to access a file straight from the hard drive would entail a significant amount of time since the data is distributed. To read a file, the computer's hard drive would have to spin hundreds of times per minute, causing delays. To speed this up, the computer system stores the file's copy in the RAM to read it. 3. It improves application performance. RAM is also used to expedite the loading of previously accessed applications. When users switch on their computers for the first time and run any program, like PowerPoint or Database Management System, DBMS, software such as Access, it takes some time to load. However, when a program is closed and relaunched, it opens almost immediately since the data required to load the application is stored in the RAM instead of on the hard drive. App data remains in the RAM until the PC is restarted or the application is force-closed from the task manager, or its non-Windows equivalents. In the case of mobile RAM, it can even refresh app data dynamically in the background to boost the device's performance. Let us first understand the physical structure and functioning of random access memory. RAM is conceptually analogous to a series of boxes where each box may store a 0 or a 1. Every box has a specific address which can be determined by counting across columns and down rows. A collection of RAM boxes is called an array, and every box is called a cell. The RAM controller transfers the columns and rows addresses down a small electrical wire inscribed into the chip to locate a particular cell. In a RAM array, every row and column is assigned its distinct address line. Any retrieved data is returned on a different data line. RAM is physically compact and stored on microchips, which is crucial. It is also limited in the quantity of information it can store. A basic laptop computer may have 8 GB of RAM, whereas a hard drive may contain 10 TB. The working of RAM depends on the following key functionalities. 1. Main board of RAM. All RAM hardware components are soldered on this circuit board. It consists of a silicon-based integrated circuit that provides connectivity across the memory components and interfaces with the computer so that the CPU and memory controller may access the RAM. 2. Memory banks for the actual data storage. This part contains the actual memory modules, or cells, that store data. RAM is always composed of 2 or more banks, enabling one bank to be accessible while another is charged. This reduces the delay in pre-charging a bank, resulting in faster transfer speeds. It also decreases the granularity of every bank, resulting in increased memory capacity and performance at a reduced cost. 3. Clocking. Memory operations in RAM are synced with clock signals. This streamlines the controller interface and removes the need for analog signal generation. It also reduces manufacturing costs for memory components, as faster memory may be generated at the same cost. 4. Mode register component. This register configures the core device operation. It regulates the column address strobes, CA, delay, burst duration, and burst type. It is often configured as the machine is booting up. Power users often need 4000 MHz RAM and a delay of CA 15 to 18 or lower for optimal performance. 5. SDP chip. SPD is an abbreviation for Serial Presence Detect. RAM is equipped with an inbuilt SPD chip that stores information on the memory size, type, frequency, and access timeline. This chip enables the computer to obtain this information during its power-on testing cycle at the startup phase. 6. RAM's burst counter. The burst counter is the on-chip counter that stores column address information. It offers high-frequency burst access by employing sequential and interleaved burst types and varying burst durations. The mode register allows for the programming of these settings. Most PCs let users install RAM units up to a specific capacity. A computer with more RAM reduces the number of times the CPU must read data from the hard drive, a slower process versus reading data from the RAM. RAM access time is measured in nanoseconds, whereas storage memory access duration is measured in milliseconds. RAM versus flash memory. Both flash memory as well as RAM consist of solid-state semiconductors. However, their responsibilities in computer systems vary due to variances in their construction, performance standards, and prices. Flash memory is utilized for storing. RAM is employed as active memory, which processes data obtained from storage. A fundamental distinction between RAM with flash memory is that information must be wiped in complete blocks from the latter. This renders it slower than RAM, wherein individual bits may be deleted. Nevertheless, flash memory is much less expensive and non-volatile when compared to RAM. It can save data even while the power is off, unlike RAM. Flash memory is often employed for long-term storage owing to its reduced speed, non-volatility, and cost reduction. Thank you for watching this video.